Academy free solar training. My name is Jessica John, and I'm the executive coordinator of Cedro Royal. So I welcome you all to this training. All right, our topic for this training is Introduction to Solar Energy. Can you all mute my people? If you can hear me, Suleiman, can you mute your mic? Thank you. All right, I said our theme is Introduction to Solar Energy and Career Opportunities in the renewable energy sector. Okay, and on behalf of the management of Cedro Royal Multi-Ventures Limited, I sincerely appreciate you for taking time to join us today. Your presence shows your commitment to learning, professional growth, and exploring opportunities in the rapid renewables energy sector. Today's training is designed to provide practical insights into solar energy, career opportunities, and also the skills required to thrive in the industry. I have participants joining us from different backgrounds, and we trust that this session will be informative, engaging, and impactful. Okay, so before we proceed, allow me to briefly introduce the organization behind this training, Cedro Royal Multi-Ventures Limited. Cedro Royal Multi-Ventures Limited is a Nigerian dedicated to advancing renewable energy adoption, economic growth across Nigeria and Africa. Can you all hear me?
Yes. Yes, please, we can hear you. We can hear you.
Energy Division and Cedro Royal Technical Advisory Services, workforce development, market creation, and business support solutions. For renewable energy companies, development organizations, and government institutions. It comprises experienced renewable energy from certified engineers and also industry practitioners with extensive experience in solar energy systems, productive use of energy, renewable energy projects, implementation, and entrepreneurship development. Our core services include solar energy and renewable energy training. We also have productive use of energy, PUE, that is capacity building. We also have solar entrepreneurship and business development training. We have renewable energy market creation and demand generation. We have technical advisory and consulting services. We also have workforce development for the green economy. We have stakeholder engagement, and our experiences include facility in-country renewable energy training programs and professional capacity building initiatives for international institutions, including RENAC, that's Renewables Academic, AG, Germany, supporting knowledge transfer and workforce development within Nigeria. Cedro Royal has successfully facilitated training on productive use of energy, solar technologies, and business development skills for over 1,000 SMEs and youth across Nigeria, supporting enterprise growth, job creation, and improved energy utilization. We have delivered practical solar and renewable energy training programs for technicians, entrepreneurs, graduates, and professionals through the Cedro Royal Solar Academy, equipping participants with industry-relevant technical and business skills. We also provide market creation, stakeholder engagement, awareness campaigns, demand stimulation, and business growth support services for organizations operating in the renewable energy, agribusiness, and also human resource sectors. Cedro Royal is committed to accelerating Nigerians' clean energy transition by developing skilled professionals, supporting renewable energy enterprises, expanding market opportunities, and delivering sustainable solutions that improve livelihoods and drive inclusive economic growth. So now, for us to move further, let's do some housekeeping. First, kindly keep your microphone muted unless invited to speak. All right. Use the chat box to drop questions during the session. If you have any question, you can drop it on the chat box. Please take notes of important points. There will be a dedicated Q&A session after the presentation. So we encourage you to be active, participate, and we encourage your participation and also professionalism throughout the training. All right. Without further I will want to invite our facilitator in person of Mr. Ojo Anthony. It is now my pleasure to introduce our facilitator for today's session. Can we all welcome him in the chat box? Mr. Ojo.
Good morning, House.
All right. Before he comes up, I want to introduce him. Mr. Ojo Anthony is an experienced solar energy professional with practical knowledge and industry experiences in renewable energy, solar installation, and energy solutions. He has contributed to training and capacity building initiatives aimed at empowering individuals and organizations with the technical skills required in the renewable energy sector. Today's session will provide valuable insights into solar technology, industry opportunities, and practical pathways for anyone looking to build a career or business in the solar energy space. Please join me in warmly welcoming Mr. Ojo Anthony. Without taking much of our time, I will now hand over to our facilitator to take us through today's training. Mr. Ojo Anthony, the floor is yours. You are welcome, sir.
Good afternoon, everyone.
Good afternoon.
Thank you, Jessica. I appreciate
Welcome, sir.
the introductory part of the section. And I welcome you all to this platform this morning. She has said much of what we are going to do today. Our basic aim this morning or today is a free solar installation training, which is tagged Solar Energy Design and Installation Principles. So we are going to tailor our lecture today on solar energy design and installation principles. I welcome you all. Here on my platform here, I think I have 18 participants, and the platform is also open to additional members who will be joining as we go on. But I will advise that please, you pick your pen and paper to jot down any area you find or you need more explanation, or any area you feel you can contribute based on your own knowledge. Our training covers both those of zero knowledge about solar energy system, those of basic knowledge about solar energy system, and those of advanced knowledge of solar energy system, as we all work together to achieve our targeted goals. Now, also, after the training, hope you are hearing me clearly, House. Good. Also, after the training, the slides of this training will be sent to you. I will give it to the coordinator, Ms. Jessica, and she will send it to you. So don't bother in case you cannot get everything immediately, or maybe you want to write from the slide and you cannot complete. Don't bother, the slides will be sent to you. So you're once more welcome. We are starting in earnest. As you can see, the training is sponsored by Cedro Royal Multiventure, and is presenting a free solar installation training by Engineer Ojo Emoy Anthony, who is talking to you now. And the term of the training is Solar Energy Design and Installation Principle. Ms. Jessica.
Yes, I can hear you. I can hear you, sir.
You hear me clearly?
Yes, I can hear you.
That's good, that's good. All right, now the first slide is renewable energy. What is there for renewable energy? Renewable energy is a clean and endless energy that is excess and can be transformed into useful energy by man for his or her daily activity. That is what renewable energy is all about. It's a clean and endless energy that is in excess and can be transformed into useful energy by man for his daily activity. So when you hear the word renewable, it means something that can be replaced without man's effort. For example, the air, the sun, the rain. You understand that those things are not man-made. They are nature, and they are produced as time goes on. So energy derived from them and is used for the benefit of man is called renewable energy. And what are the classes? The classes of renewable energy we have include number one, the solar energy system, otherwise called the photovoltaic energy. Number two, we have the hydro energy, which is the energy
Hello,
generated by water.
we are not seeing your
Number
slide.
three, we have the please, some mic are on. You can please mute it for better understanding. Number three, we have the biomass. And the biomass deals with the decays of nature that produces energy. So, the second slide is solar energy, which is the key point of what we are going to discuss today. What is solar energy or photovoltaic energy? When you hear the word solar energy, it can also be called photovoltaic energy. Therefore, what is solar energy? Solar energy is the conversion of the energy of the sun into a form of energy, otherwise called direct electricity, that is used by our home appliances. It is the conversions of the sun, of the energy of the sun into electricity that is used by our appliances. The word photovoltaic comes from two different words, and it is a compound word of photo and voltaic. What is there for photo? Photo means light. Voltaic means related to electricity. So when you join two of them together, it means the energy from the light that is transformed into electricity for use by man. That is what is called photovoltaic energy. Now, there are components of the solar system. There are components of the solar system. Our signal from the both can signifies that we are following, please. Anyone that you feel that you understand or you're following, please, you can signal to show, since your mute is off, to know the direction we are going. Now, component of the solar energy system. Number one is the solar panel. the solar panel. And what is the work of the solar panel? The solar panel is used to collect the sunlight, otherwise called the photon. The work of the solar panel is to collect the sunlight, otherwise called the photon. Number 2, we have the charge controller. And what is the function of the charge controller? The charge controller is used to stabilize the current flow from the panel to the battery where the current is stored. Number 3, we have the solar inverter. And what is the work of the solar inverter? It is the central equipment that convert the DC current, the direct current of the solar, or as in of the current collected by the panel, into AC current that is used by our appliances. Or it also does the work of rectifying the AC current from the battery, as in from the grid, to DC, which charges the battery also. So that is the work of the solar inverter. Then finally, number 4, we have the solar battery. And what is the work of the battery? As we all know, it is the equipment among the solar energy system that is used for storing of charges from the panel or from the grid. Then from there, we'll proceed to solar cell. Now, when we talk about solar cell, it is the component of the solar panel that we're talking about. What is the solar cell? The solar cell are the units of the solar panel or the solar module that convert the sunlight into electricity. They are the units of the solar panel or module that convert the sunlight into electricity. I know we are conversant with the solar panel. When you come close to the solar panel, you discover that there are pallets of units that are in same array, that are in arrangement. Each of those pallets or each of those units on the solar panel is called the solar cell. And that is what we are talking about. Each of them generates electricity. And when it is combined, it is sent to power our appliances. But there are things we must have to know. There are names that we call them. The solar cell is the smallest unit. And when components of solar cell combine together, they form the solar panel. Sometimes in an engineering terms, we call them solar module. So when you hear the word solar panel or solar module, they are the same thing. They are not different. They are the collections of same solar cell. They are the collection of same solar cell. Then when these solar modules are arranged or are put together, they are now called solar array. Solar array. Solar array is the combinations of multiple solar panels. Like when you go to your friend's house and you see 3, 4, 5 solar panels on the zinc or on the roof, those arrangements there, they are called solar arrays. You will now put it in sentence in the form that I saw solar arrays of panels on the roof, and that is all. So how do solar cell work? How do solar cell work? There are 3 stages that the solar cell use to change the energy of the sun into useful energy by the home appliances. The first stage is the light absorption. Light absorption. The word absorb means to collect. Absorb, to collect. For instance, if you flash or if you pour water on a mattress, you discover that the water will not bounce off the mattress. The water will be absorbed by the mattress. So also is the light of the sun. The solar panel is made of components or elements. The major element is silicon, It's made up of element that has the ability to absorb the sunlight. The sunlight is also called photon. Now, light absorption. And what is light absorption? It is when the sunlight hits the solar cell and it is collected. That is the first stage. The second stage is called electron excitation. Electron excitation. Then what is electron excitation? The component of the solar panel is made in the form that their electrons are in stable state. Their electrons are in stable state. But when the sun hits the panel, those stable electrons now are excited. Another word for excited, you can call it agitation, or they are disturbed. A simple explanation of it is when you throw a stone into the water, you discover that the water will be disturbed. So those electrons that are stable and are resting, as the sun hits them, they become disturbed. So the photon, which is the sunlight, excite or disturb the electron of the panel materials. Like I said earlier, the major component for the panel production is silicon. And silicon has the ability, its electron has the ability to be excited. So when the sun hits the panel, the electron of the material of the panel is excited or is disturbed. Then number 3, which is the last, is current generation. Now, when those electrons are disturbed, they flow through a conductor called the wire, and it is sent into the charge controller for energy generation. The excited electron now then flow through a conductor to generate electricity. So these are the 3 stages how solar cell work. These are the 3 stages. Number 1, light absorption, which means collection of the light. Number 2, electron excitation, which means the panel electron is being disturbed or excited. Then number 3, current generation, which means the disturbed electron is being transferred from the panel through a conductor for use on our home appliances. So that is how it works. Now the next slide talks about the classifications of the photovoltaic cells. Classification of the photovoltaic cells. Now when I say photovoltaic cells, I mean the solar panel cells. When you talk about the cell is the smallest unit of the solar panel. So when we discuss the cell, automatically we have discussed the panel. So note that the cell and the panels are not different. The cell and the panel are not different, but collection of cells form the panel. So we take a cell and discuss it. Then the quality of that cells is what determines the quality of the panel we are discussing. Now, photovoltaic cells are classified into 2 main groups. The first group is the main type of the photovoltaic cells. The first group is the main type. Now, what is the main type? The main type are the ones that are made from existing elements. You all know that in the periodic table we have 109 elements, and we have them in groups and in periods. So, number 1 of the main type is what is called the monocrystalline photovoltaic cells. Monocrystalline photovoltaic cells. Now, what is the monocrystalline? It is the major solar panel used by many in Nigeria today. They are dark in color, they are uniformly blend, and they have high efficiency. The monocrystalline has efficiency of about 15 to 20% efficiency. It has efficiency of about 15 to 20% efficiency, which means it is high. Number 2 of the main type is the polycrystalline. Polycrystalline, they are gray in color. They are not too dark, and the efficiency is lower than the one of monocrystalline. It has efficiency of about 13 to 16%. 13 to 16%. Then the last type of it, of the main type, is the amorphous or the thin film. Amorphous or the thin film, and it has lower efficiency of about 10 to 12%. If you take a look at your torch, you take a look at your radio and some other small appliances where you see that they are solar, as in they are solar supported, those things used there, they are called thin film or amorphous. They are non-monocrystalline. They are like leather, they can bend, they are not strong, and their efficiency is very low. They are only used for minor appliances like your power bank, like your radio, and so on. Then the second group of the classification is the emerging type. Emerging type. Now the emerging type are those types that exist out of discovery. They are the type that exist out of discovery. Now, one of it is the organic PV, organic photovoltaic. We have organic. Now, what is organic? Organic are natural substances that are used to produce the solar cell. When they say organic, you all know, you all have organic manure, just like the dungs from the cow, the dungs from the fowl, and so on. They are organic. So we have organic PV. Most of those things are not used here in Nigeria because research is still on the way. But in some developed countries, we have all those things. They don't use solar panels. They use organic PV. We have also the perovskites. The perovskites, they are also an emerging type that countries or people use to generate energy. Then we also have another one called the graphene base. The graphene base is another form of the emerging type of the solar cell, and so on. As this goes on, discovery are on the way, and every day with research, you discover that many of the emerging type of the solar cells are coming on, and we'll be posting it to you as time goes on. So, having talked about all this, the photovoltaic cells, its classifications, the efficiency, and how it works. How can we relate it now to electricity that will help us to generate power? That will help us to generate power. Remember, our topic is solar energy design. And before you design a thing, you must have the first-hand knowledge of what you have in mind or what you want to do. So please, once again, I will remind you that any question you have, pick a pen and paper, write it down, and as time goes on, an ample time will be given to you to ask your questions, and a clear answer will be given to you as we go on. So the next slide talks about electricity and the solar power. What is then electricity? Many of us, almost all of us, have electricity in our home. But what is electricity? Very, very important. Electricity is the flow of tiny particles. The flow of tiny particles, otherwise called charged electron, through a conductor to power our appliances. Electricity is the flow of tiny particles called electron through a conductor to power our appliances. Key word there, tiny particles or electron. What is tiny particles? They are also called charged electrons. Charged electrons. They are passed through a conductor. Another key word there is conductor. You don't connect stick to a wire and expect a result, but you connect conductors. And what are conductors? Conductors are elements that allow the passage of heat and electricity. Example, copper. Example, zinc. Example, aluminium, and so on. All these are conductors. Their work is that they allow heat and electricity to pass through them. Now, having known what electricity is, what are the key electricity terms? Key electricity terms. Number one of it, which is very, very vital, is the voltage. What is voltage? Voltage is the push or force that moves the electron through the conductor. Electron don't just move. Something force it or something push it to move through a conductor. So it means voltage is measurable. Voltage is measurable. Because for it to move, to push an electron through a conductor, it needed what? A force. It needed stability for it to push through a conductor. Number two key word is current. What is current? What is current? Current is the amount of electron that is forced or pushed by the voltage at a particular time. It is the amount of electron that is forced or pushed by the voltage at a particular time. And the unit of current is ampere, while the unit of voltage is called volts. The measuring unit of voltage is volts. The measuring unit of current is ampere. Most of these units are named after the discoverer, people that discovered them. But we are not into that this morning. The third key word is resistance. What is resistance? Resistance is the external effect that opposes the movement of those electrons through a conductor. They are the external influence or effect that opposes the electron movement through a conductor. This can be what? This can be as a result of what? Heat. Temperature is one of the major resistance. Number two, wire size. Wire size. Whenever you want to where you should use 6 mm wire and you use 2 mm, you understand that the current that will pass through will need 6 mm. And for that reason, the 2 mm cannot handle it, so it causes resistance. It causes resistance. It's like many of us on this platform. You discover that as great as you are, you cannot use a 6-year-old clothes. I think it's not possible. It's not possible. So when undersized wire is used, it causes resistance. When the temperature is too much, it causes resistance. And other factors, for instance, now in this solar energy, shading is also a resistance. A solar panel needs to be exposed to the sun. If you discover that there is a tree close to the house, I will go to meet, we'll go there. When we go to design, I will tell you all of this, but let me hint it here. When you are placing your solar panel on the roof, you must discover the direction of the sun. Because if the leaf or the tree stay close to it and shade it, it causes resistance. And these are external effects that opposes the flow of current. Another example of resistance is partial contact. Partial contact. As time goes on, and for many of us that will be with us, as in that will register with us to go on, we will be discussing the equipment used in the connections of solar energy system. And we'll be telling you the classes of this equipment. There are equipment that can withstand moisture, which is rain or water. There are equipment that can withstand sun. There are equipment that can withstand heat or fire, and so on. We'll be discussing them as time goes on. But let's talk about the design this morning. So resistance is an external effect that opposes the flow of electron through the conductor. Then the last key electrical terms here is power. What is power? Power is the rate of work done to push the electron through the conductor. The rate of work done to push the electron through the conductor. And by formula, power in electricity is equal to current times voltage. Power is equal to current times voltage. Now we'll go on. Now that is it. Those are the key terms. Now what are the type of electricity? I am giving you this basic background so that when we go into the design or as time goes on, you won't be confused when names and terminologies are used. Because you don't expect me to call some names for you that you will not understand. As soon as you don't understand the meaning of those names, the application of those things will be useless because you might wrongly apply them. And that's differentiating you that is undergoing this training and a roadside technician that tends to learn it halfway and go to the field. If you look at today, there are homes that are burnt, offices and grids that are set on fire today because of wrong connections, wrong sizing, and wrong configuration. And we are experiencing that every day, all over the country, even outside the country. So the right sizing and the right information will give you the right result. What are the type of electricity? Number one, we have the direct current. The direct current electricity. And what is direct current? These are currents that flows only in one direction. They are current that flows only in one direction. They are produced by the solar panel. The current from the solar panel is a DC current. The current from the battery is also a DC current. But the current from the grid, which is NEPA, as many of us may know it, is never a DC current. You get it? It's not a DC current. And why is it very important for us to know it? Because there are DC wires that are used for connecting a DC current. And also there is an AC wire that are used in connecting an AC current. But today market, technicians and people decide to mismatch using any kind of wire they so fit, and as a result causing dangers to homes and families. Now, what are the type of connections? The type of electricity connection. Number one type of connection is series connection. The appliances in solar energy system can be connected in series. What is series connections? Series connection is the connections of the two different polarities. We have two polarities, the negative and the positive. So when negative terminals is connected to the positive terminals, and the negative terminal of that battery is connected to another positive terminals, and so on, it is called series connections. The practical example is for 5 boys to stand facing the same directions and moving side by side to themselves, hand sideways stretch, as we do in primary schools and so on. When you do your hand sideways stretch, those by your side, you are connecting to them in series, because your left hand will meet the right hand of the next one, then the left hand of that one will meet the right hand of the next one, and so on. So that connection is called series connection. But what is there for the benefit of the series connection? Please, the benefit of the series connection is that the voltage add up, but the current remains fixed. For example, If I connect, let's use battery as an example. The solar battery has negative and positive polarities or terminals. When I connect the negative of battery A to the positive of battery B, the negative of battery B is connected to the positive of battery C. That connection is a series connection. And if each battery is 12 volts each, it means 12 plus 12 plus 12 will therefore give me 36 volts. Hope you all understand. It will give me 36 volts. The voltage will add up. But in that case, the current of that battery remains the same. If all the battery has what? 120 ampere, it means after connecting those three in series, my result will give me 36 volts, 200 ampere. The ampere will not change, but the voltage will be added up. Hope we are understanding. Good. The second type of connection is the parallel connection. The parallel connections. Thank you very much. Thank you. Let's go on. Thank you. I'm seeing it. The parallel connection. What happened in the parallel connections? In the case of parallel connections, the same polarity are connected together. Example, I have three batteries, battery A, battery B, battery C. If the positive terminals of battery A is connected to the terminals of battery B, and the positive terminal of battery B is connected to the positive terminal of battery C, and the output is gotten, then the same thing to the negative terminal. It means those three batteries are connected in parallel. And the practical examples is hands forward stretch. You all went to, I attended a primary school, and to date I can remember hands forward stretch. And hands forward stretch means that your two hands will be on the neck of your neighbor in front of you. So your left hand is moving to his left shoulder, your right hand is moving to his right shoulder, and that person, his or her right hand is moving to the right shoulder of the next person in front of him, and his left hand is moving to the left shoulder of the next person in front of him. So that arrangement is a parallel arrangement. That is a practical example of parallel connection. The same polarity are connected together. Then the output is obtained. And in that case, what happened? The current will be added up, and the voltage will remain the same. For example, let's assume we are still using the battery 12 volts, 200 ampere. The result we will get in connecting three of these batteries in that conditions will be that the 12 volt will remain 12 volts, but the current now will be what? 600 ampere. Hope you are getting it. The current now will be added up. That is 200 plus 200 plus 200. You get it? But the voltage will remain fixed. That is the target. So if there is no any fixed connection anywhere. It all depends on what you are aiming at to get. Because when you do your design, which you are going to go into it, when you do your design, it is from then on that you know what you need. Then, finally, on that slide, the third aspect of the connection is series parallel connection, which is common in almost everybody's homes, appliances, connections, and so on. The series parallel connections harness the combinations of both the series connection and the parallel connection. It uses the connections of the series and the parallel. What are we targeting to aim at? We are aiming at a balanced state of the voltage and the current. Because each system or each inverter has a specification. They have a specification. every inverter on its nameplate, it is called nameplate, those badge that is attached to it, they have what is specification. There is an amount of voltage that it can take. There is an amount of current it can take. If you look at most of the connections that we have out there, we have 1 battery, 2 battery, and 4 battery. It will be rare for you to see 3 battery connected in series, because each tubular battery has 12 volts. So the nominal voltage of most inverter, the smallest inverters, is 12 volts nominal voltage. Some inverters like 3.5, 4, 5 kVA, they have what, up to 24 volts. Then most inverter in the market today, they have 48 volts. And how many 12 volt do we have in 48? 4. That is why most people at home has 4 batteries connected in series to match up the nominal voltage of the battery of the inverter. Otherwise, the inverter cannot recognize the battery and the panel cannot be able to charge it. And for people who are using charge controller, the nominal voltage is on the charge controller. So we have a 12 volt charge controller, we have 24 volt charge controller, we have 48 volt charge controller, and so on. The current also varies, so you don't go beyond it. That is the reason why we have series parallel connection. So from your design, you will know the number of series you need and the number of parallel you need to match the inverter that you have. So these are the 3 types of connections of the appliances that we have. Please jot down your questions or jot down your area you are not clear with. We have all the time today to clarify you. Next is load assessment. Load assessment, now we are going into system design now. Load assessment. Because of the time frame of this lecture, there won't be time for detailed knowledge about it, but we'll give you 100% of what you ought to know. Some practical influence or practical touch, practical application of these things will be done as time goes on. But today we'll be giving you some of the things you need to know being a prospective engineer in the future. Now, what is load assessment? For instance, I, as an engineer or a technician, is called upon by Mr. A to install solar in his house. There are key questions I will need to ask the client. And the question is not what is the number of rooms you have. No. Many installers are doing that mistake. It is possible for somebody to live in 3-bedroom bungalow and have more or have lesser load than somebody that is living in self-contained. It is possible. Somebody can be living in duplex and have lesser load than somebody that is living in 1-bedroom flat. Designing a solar energy system do not depend on the state of your house or the number of rooms. It depends on the appliances you want to power using the solar energy system. It depends on the appliances you want to power using the solar energy system. So that makes load assessment to be a very key factor when designing a system for your client. Therefore, what is load audit or load assessment? Load assessment is the summation of the daily energy consumption of the appliances that will be connected to the solar system. I repeat, it is the summation of the daily energy consumption of the appliances that will be connected to the solar energy system. For example, Mr. A has 2 deep freezers, 5 AC, 1 water pump, 15 lighting points, 2 standing fan, and a decoder. And he's living in 1-bedroom apartment. Mr. B is living in a duplex, but he has 15 lighting points, one television, smart television, 3 AC, 3 solar AC, and he has no water pump. You don't expect the same capacity of design for both of them. What you ought to do is to know those things that he wants to power. For instance, Mr. B might say, even I have this little number of appliances, I will not want to power all of them. I need the AC in my bedroom to be powered. I need a standing fan in my parlor to be powered. And I need a lighting point or the security point to be powered. I don't want the water pump to be powered. He is trying to cut down costs. In that case, we will be considering the critical load, because he's talking about critical load, those loads that are very important to him or to him. He's not talking about all the load. So you as an installer or you as an engineer, your design will center on those selected loads. And it is very, very possible. When the NEPA comes, or the NEPA light, which is the grid, when it comes, it powers all the loads. But when the NEPA is off, those selected load will be the load that will be powered. And you do not need to go and change or switch anything. It is an automatic, depending on your selection. So, load audit now take in the energy consumption of the appliances that will be connected to the solar energy system. Another thing to consider in that regard is that not all the appliances are used throughout the day. Not all the appliances are used throughout the day. So it needs to be considered. Another consideration is not all the houses or not all the places you go functions in the day or in the night. For example, when you are called upon to power a primary school or secondary school, you understand that the functioning of the secondary school is only in the day. The night time, there will not be. I'm talking about day school now, not boarding school. The night time is not involved. So your focus will be directed to the supply of power in the day. In that case, the solar panel will be given much consideration than the battery. But if you are asked to come and power a hospital, for example, a hospital, you understand that just as the hospital is important in the day, it is also important at night. So you consider a design that will supply them power in the day and also have reservation in the battery in the night. Because any sick person can be attended to. Or if you are designing for homes, everybody returns from home in the night to sleep and they need power. So your consideration should cover all of that. So when taking load audit, a lot of questions will be asked. You will need to ask the client a lot of questions. When did you close from work? He will tell you, I closed from work by 5. So if he closed from work by 5, the time of taking from the panel now is like 1 hour, because by 6 the sun must be going down. So the consideration will be laid much on the battery, which will be like a backup to his expectations, because he will want the light to be throughout the night, and tomorrow morning he will set out again and go to work. So all these are things that we need to know. And as prospective engineer, when you know all those things, it will give you an edge over people that are already in the market. So that is what load assessment. I will send you the slide, like I promised. Now, another means of taking the load assessment is some persons, or maybe you go to a place they are paying what? NEPA bills. You can use the NEPA bills to determine the energy consumption of that area. For example, if Mr. Ojo spends 300,000 naira as monthly NEPA bill for his plaza, let's assume I have a plaza and I'm spending 300,000 naira as NEPA bill per month. what is the energy consumption of my appliances in the plaza. How do I know it? I can know it. You being an engineer, you pick up a pen. And the question is, how much do you pay per 1 unit in your area, or depending on the band that you are? Assuming you're paying 300 naira per unit, each unit is 1 kilowatt, and 300,000 naira is what you pay per month for NEPA bill. When you divide that 300,000 naira by 300, you are getting 1,000 kilowatts. That means every month you are consuming 1,000 kilowatts. But you will not stop there, because what you are looking for is not monthly energy consumption. What you are looking for is daily energy consumption. So how many days do we have in a month? 30 days. So dividing that 1,000 kilowatt by 30, it will give you 33.3 kilowatts. So you will know that that plaza is consuming 33.3 kilowatts per day. That is what the plaza is consuming. You don't need to take load audit as that. You calculate it based on the NEPA bill they show you. The plaza is is consuming 33.3 kilowatts every day. So that is what you have to know. But some persons, those kind of things won't give you an accurate result, in the sense that sometimes those appliances they are based on average. Because what I consume this month might be different from what I consume next month and so on. That is why practical load audit is necessary. And if you go to the home, on my slide here, I have a sample of how the table is prepared. We'll take it in tabular form. The first column, it is made up of 7 columns. The first column talk about the serial number. You number the appliances. You number the appliances. The second column will talk about what the appliances itself. You have to name the appliances. Is it light? You name the light. We might have different form of light. Be mindful to separate them or to distinguish them. You don't expect a 12 watt energy saver bulb to give you the same thing as 50 watt security light. They are different. Light is not light in terms of design. So you go to the house, you move around, and you count those things. So when you write the appliances, on the data sheet of the appliances, the wattage is recorded there. What is the wattage? The power rating. Most energy saver bulbs that you see, they are 12 watts, we have 8 watts, so we have 5 watts, those smallest one. And those security light that you see outside, some you have 200 watts. If you go home, you will take a look at it, you will see all those things. The power is rated in watt. So when you take their watt in the third column, the fourth column will talk about the quantity. How many of the security light do you have? If I have 5 security lights and the wattage is 200, therefore the last column now will give me total wattage. 5 times 200 will give me 1,000 watts. So my security light is what? 1,000 watts. If the person has 2 standing fans, and each of the standing fan is 80 watts, it is 80 times 2, which is 160 watts. You prepare the table, and at the end, you add up the total wattage. That power rating now will help you to design a very good system that can handle the load. Many clients are crying today because of wrong design. Many clients are complaining today because the designs are not done properly and it's affecting the output. Because when your design is not done, it is time wasted. And sometimes it is detrimental, it is very dangerous to the health of the client. Due to what? Fire outbreak or damage of big appliances. So please, we need to put that into consideration. We are close to the end. I am seeing the time, and please be patient so that we'll come to the end of it while we answer 1 or 2 questions and we go further from there. The next one is system performance calculation. For you to have a good performance of your system installations, there are three things you must consider. I have mentioned one already, but as time goes on, you'll be getting to know other things. Like I told you, this area is targeting on design and installation principle. I am not talking about safety principle here. I am not talking about equipment calibrations and sizing here, but we are just talking about design. So please, solar energy system is a very vast knowledge, and subsequently we will get to know all of those things. Now, system performance calculations, we need to consider three things. Number one, site assessment. Site assessment. What is site assessment? Site assessment means that you, being the installer or the engineer, it is your duty to go to the site of the client. You don't sit at home and somebody will bring information for you and say, I want to power my house and this is what I have, this is the location of my house, this is it. No. Take your time, follow him to the site or to his house. You will now see the direction of the sun. As you all know, the sun rises from the north to the west. So when you are facing your panel should face east, south, as in southeast direction, so that the sun can run over it. If you face your panel northwest, there is a period of time that the sun might not meet up, and you see that the delivery or the product might not be what accurate or be good, and in that case they will call you bad installer. But when you go to the site prior to the installations, you will get to know all of these things. I have an applications and apps that can decide the direction of the sun and so many things to give. But as time goes on, we'll get to know about that. The second one we need to consider is load audit, which I have just talked about. After assessing the site and discover that the site is okay, you take your load audit. Then the last one is the system sizing. System sizing, we are not going to go into the detail today, but system sizing is the art of determining the capacity of your inverter, the capacity of your battery, and the number of panels and their capacity. You don't use any kind of panel for any kind of job. You don't use any kind of battery for any kind of job. You don't use any kind of inverter for any kind of job. It depends on what your audit gives to you. It depends on what your assessment gives to you before you use. You getting me? For example, if the persons want to power water pump, for example, you don't expect to use pure sine wave inverter or IVPS. You are to use IVPM or transformer base. You have to use transformer base. Why? Because the startup current of water pump is high. When you use pure sine wave inverter, over time or within the shortest period of time, it might develop fault because it cannot handle it. It's a low frequency inverter. Are you getting it? So you're using what transformer, but we'll go into that in detail. Now, inverter classifications based on voltage, which is what I have just said. The first one that we have is high voltage inverter. Inverter classification is based on two things. Number one is based on the voltage. And on the voltage, number one, we have high voltage inverter. What are the high voltage inverter? The high voltage inverter, they have input DC voltage range of 100 volts and above. In here, high voltage inverter is not used majorly for homes. It is used for industry. For instance now, if you want to install for a community project, you don't expect to use low voltage inverter. There are inverter that has a voltage of about 600 volts, very high voltage. So they are used for industrial purposes and they are very rugged. Most of them are standalone inverters. Are you getting me? So number two, we have low voltage inverter. They have input DC voltage of between 30 volts to 100 volts. Those are the inverter that we use in our homes. If you go to many homes and families today, you see those inverters there. If you look at it, the voltage level is between 30 to 100 volts VDC. Sometimes it might grow to 145 or 150, but it's still low voltage inverter. It's still low voltage inverter. Your 3 kVA, 2 kVA, 5 kVA, and so on. Sometimes 7 kVA, they are low voltage inverter. So those are the inverter classification based on voltage. We also have inverter classification based on performance. Inverter classification based on performance. Number one of it is the stand-alone inverter. Stand-alone inverter. Stand-alone inverter. I am seeing some message. I told you we are going to give, I'm sending the slides to the platform. You will get them all. So please don't be perturbed. You will get them and you will follow it stage by stage. Everything I'm saying, you will follow it up. It will be sent to your email. I will coordinate with Jessica and to the management and will send it to your email so that you have the basic knowledge of all that we've done, the full knowledge of all that we've done today. So the second one is the grid tied. Standalone inverter. Let me explain. Standalone inverter. Those inverter, they are not common here in Nigeria. They use battery for performance. They use battery for performance. They are not common here in Nigeria. What they do is that they are not connected to grid. They are not connected to grid. They use battery for performance. If you look at most of there are people who have them because most people now patronize hybrid inverter, hybrid. But there are people who have standalone inverter. What they do is they can't function without the battery. The battery is the base with which they function. Then number two, we have the grid-tied inverter. The grid-tied inverter, they don't need battery. They collect the sun directly and powers the home. But the excess energy is channeled back to the grid. We don't do that in Nigeria most. Because Nigeria, I've asked a lot of questions, I didn't get that in Nigeria. If you go to UK, if you go to England, USA, and so on, you discover that the excess energy that is not consumed by individual is sent. It's not just wasted, it's sent to the grid. And as a result, your NEPA bill in such country will be reduced because just the way you are paying for NEPA bill, the government of that country also pay for the returned energy you send back to them. So grid tied means NEPA tied. You are exchanging. NEPA is given to you in the night or where there is no sun. Then you are giving back to NEPA when you have excess of the energy from the sun. So it's called grid tied. Then the commonly used inverter here is the hybrid inverter. The hybrid inverter is the combination of the standalone inverter, which uses the battery as base component for performance, and the grid tied, which has the ability to take from the grid also. And that is what we use at home, where the inverter can charge your battery from the NEPA and can also charge your battery from the panel. If it is night time and the panel is not giving out power, the NEPA now can charge your battery. Then when the NEPA is off, the battery can now give back to NEPA, as into your appliances at home, and it will function. So that is hybrid. But in our day-to-day, or the language that we always hear in the streets, people assume that hybrid is an inverter that has internal charge controller. It is not so. There are standalone that have internal charge controller. There are grid ties that have internal charge controller. Inscribing internal charge controller to it does not make it a hybrid. It's a misconception. It does not make it a hybrid. Hybrid is a combination of standalone inverter and grid-tied inverter, meaning that inverter works uses battery for performance, and can also give to the grid or take from the grid when the need be. That is hybrid inverter. Now, slide 10, which is the second to the last slide, we are going to be talking about the final thing here, which is very, very important, and that is protective devices and cabling. Protective devices and cabling. What are the protective devices? The word protective comes from protect, to secure a thing. There are the electrical devices that detect fault current or regulate the voltage and disengage them from entry and appliances. This is the work of the protective devices. And here is very, very important. You must have done a very good work, but if you don't size the protective devices very well, your work is as good as nothing. Why? When thunder strikes, when there is a short circuit means when two naked wires touch themselves, there should be a device that should break or trip off, that will not allow an electricity to go into your appliances to destroy them. But if those devices are not sized correctly, they will allow the electricity to enter and destroy the appliances. And that is why many people are still crying. I installed yesterday, the thunder that blew in the night break my televisions, it spoiled my inverter, it spoiled this, it spoiled that. This aspect is very, very important. But technicians, installers, and many engineers are not giving it due attention. They are not giving it due attention. The protective devices or the device that you will use for 5 kVA inverter is not the same thing you will use for 2 kVA inverter. Even from the name, you know that their sizes differs. And all this is based on sizing. You need your pen, you need your paper. You must write. You must know the number of the power or the capacity of that appliances. Then the voltage that passes through. Because most protective devices are measured using current. So when you divide the power by the voltage, you will now get the current. And when you get the current, the closest capacity of your protective device will be used. For example, don't quote me, but let's say, for example, I am having 5 kVA inverter to install. And the inverter is a very good inverter with power factor of 1. Let's say if it is power factor of 1, the 5 kVA now is the same thing as 5 kilowatts. Now, what is the breaker I need to use as an AC input of that inverter? My work is simple. 5 kVA or 5 kilowatt is equal to 5,000 watts, which is the power capacity of the inverter, and is 5,000. When I divide it by the voltage of our nation, Nigeria here, which is 230, the voltage is between 220 to 230. I'm talking about AC voltage now. When I divide it by 220, I will be getting something like 17 point something ampere. But because it's an input breaker I want to install, I must also consider charging current. So I will multiply that AC now, as in that value, which is 17 point something, by I will assume a charging current of 80%. Charging current is not usually the same thing as the obtained current. But for security purpose, you can multiply it by 2. But me, I will multiply by 80%. And when I multiply it, it will give me 28, 30. So automatically, the breaker I should be looking at should give me 32 amps breaker. I should use 32 amps breaker, which is the closest number after 30 or 28. 32 is in the market. You will use 32 amps breaker. But many installers will go for 63 amps. Some will go for as far as 100 amps. It's like wearing a 4-year-old child. a cloth for 12 years old man, and it will be an oversize. So that breaker will just be there. It will not stop the as in the connection, but it will not protect what it should protect. That is the danger. It will not protect what it should protect. So that is it. We must consider it. Then what is cabling? Cabling is the wires that we use to connect. It must be sized accurately. There is a formula for sizing of wire. All these formulas we will come to a point where we'll do the calculation practically, and you will see the reality of it. There has formula. For example, now most sockets, you don't use the wire you use in connecting socket. Let's assume you have 13 amp socket. It's possible for you to use 2.5 mm AC cable. Very fine. You can't use that same wire to connect an air conditioner. An air conditioner requires higher mm of wire. You can use 4 mm. And you cannot use that same wire to connect for cooking, let's say oven, cooking tools in the kitchen. They are high capacity equipment. You need wire like 6 mm. But if you go to some houses today, oven, washing machine, they are using 2.5 mm. That is very, very dangerous. Dangerous to life, dangerous to the equipment. So all this must be put into consideration. And as time goes on, we will get to know them. Another protective installations that we have, they are lightning and thunder arrestors. If you go to people's houses, you see their zinc, a kind of cross or maybe iron-like substance on the zinc. They are thunder arrestors. What is the work of the thunder arrestors? They direct the excess spike from the lightning into the soil. They don't seize it up, they direct it. It runs through that thing. Instead of running to spoil something in your house, it will run and go into the earth, which is the soil. Another one that we have is the overcurrent protective device, OCPD. Overcurrent protective device, what they do is that they control excess current into the system. Just the way your mouth controls the amount of water from the cup. You don't expect that you put the cup in your mouth and all the water leave the cup to your mouth at the same time. Your mouth controls it. So overcurrent protective devices control the excess current. When the current is much, because the voltage has pushed them much, they will now tell some current, you don't need to pass now, this one pass. They control it. Are you getting me? Into the system, so that the system will not just observe such kind of huge current and get damaged. Conclusively, we are rounding up now. Conclusively, I must tell you that solar energy system is one of the fast-growing technology in the world today, and it has a vast benefit. Benefit of durability, benefit of reliability, benefit of eco-friendliness, and many other benefits. It's a very fast-growing technology. The lecture you are having now is what somebody else in Canada, somebody else in USA, somebody else in Russia is having, because the principle is the same all over the world. We in Africa, we are lucky that we have more sunshine compared to those places, but still they are using it. Number two, it is a major source of employment in our world today. I know many of us want to grow our wealth. We want to improve our financial income and so on. And we are looking for a way out. This is an opportunity for us. You can go into it as an installer. You can go into it as for sales and services. You mustn't go into it. Not everybody must climb the zinc. Not everybody must hold the wire, or many of you have phobia for wire, for electric shock and so on. But you can do sales and services. And you need this information because you must communicate to your clients what you are giving them. Sometimes they might demand you to size it up for them. With this knowledge, you can have more sales than people in the market because you have the ability to give them the right sizing. Some of us that are into installations and engineering aspect of it, we are benefiting hugely. It's a major contract in the world today. Some people go into it for consultancy sake. You can consult for companies, for industries, for homes, for families. You can consult. Staying in the gap between the seller, as in the seller of those products, and the client who want to use the product. You can stay in the gap between them and make your money. Some areas include design and procurement. If you go to some companies, the work of some persons is to procure materials, and there is money in it. It's an employment. There is money in it. Because when you go to the market to buy and you resell it to people who are in need of it, there are ways that you charge your cost and you get your money. Some go into it for advisory services. What should I do? My solar is this. What should I do? You can advise them and you get paid for it. Number 3, it is eco-friendly and cheap to maintain. If a solar energy system is correctly installed, it is very, very friendly. Very, very friendly. No noise pollutions, no air pollutions, no sound pollution. You don't hear anything. You can stay in, if provided it's in a conducive environment. Actually, for safety's sake, it's not advisable that the batteries and all those things stay close to where you sleep at home, but it is not as dangerous if it is well installed and well sized up. And mind you, some batteries are not tubular batteries. They don't have acid in them. They are made of lithium, so they are friendly. Then number 4, it is cheap comparing the upfront cost of grid power system. When I say this, there is a contradiction in the mind of some persons right now, but it is cheap. An average lifespan of a solar panel is 25 years. The only thing is that the initial cost is high, but considering the upfront cost of grid payment, for example, a plaza that pays 300,000 naira as grid, as NEPA bill per month, if such plaza uses 30 million naira to install a grid or a mini grid that serve the plaza, before 20 years, they must have spent more than that money paying NEPA compared to the installation. The initial cost might be high, but considering the upfront payment, it is very, very cheap. Very, very cheap. So it's also an advice or a kind of giving knowledge to your clients when you want to talk to them about the solar energy system. If you go out today, one of the languages that I don't have money, I don't have money, I don't have money. Yes, there is no physical cash for startup. But if it is installed, it is very, very cheap because over a long period of time, you will not have a problem with that. And just like the panel I said, both the battery, they have warranty written on it. Every lithium battery has warranty of about 5 to 10 years. Within those warranty period, if there's a damage that is not human fault, you can take it to the company and they are responsible for the repair or other remedies. They are responsible. So it is very, very cheap. Then another point is that it is highly durable and can last for 20 years and above. If properly maintained, it is highly durable. Then lastly, the knowledge of the solar energy system can be applied anywhere in the world. This is very, very important. The training you are gaining today can give you a job in USA, it can give you a job in England, it can give you a job in Sweden, Canada, anywhere. The same thing I am telling you today is the same thing that is being taught out there. So the applications of this training is worldwide. It's not Nigeria based, it's not Kaduna based, it's not Kano based, but it's nationwide. it is worldwide. So the knowledge of solar energy system can be applied anywhere in the world. So once more, I am Engineer Ujo Emoy Anthony, a current certified engineer, and I appreciate your time out on this platform. I appreciate your time out taking throughout this lecture, and I look forward to having you as time goes on. So I am handing the platform now to the coordinator, the person of Jessica John, to take it off from here. Thank you very much. You're welcome.
Thank you so much, Mr. Thank you so much. That was an impactful and presentation, and we are so grateful. I have learned a lot, and I know that for everyone that is on this call has learned one or two things. So we are so grateful. Now we will continue with we have questions. For anyone that has a question, you drop it in the chat box so that our facilitator will answer the question. So if you have any question, drop it in the chat box. While we are doing that, there will be a certificate at the end of this training. So I would like you all to write your name the way you want it to be on the certificate. Write your name the way you want it to be on the certificate and drop it in the chat box. Do you have any question? We are waiting for your question, please. I don't know if okay. Let me allow you. Mr. Yusuf, you can go on.
Please, can you hear me?
Yes, we can hear you.
All right. My basic concern is not basically a question, but I don't know. This I want to thank Mr. Ojo for the wonderful presentation. I think he has done justice to it. But for some of us who are actually novice to solar installation vetting, I think um, this 1 day or 1 hour training is not enough. I don't know if we can have another session where it can project the slide, so the slide will serve as probably a practical section since we cannot have a physical this thing. So when you explain, if we can see it on the screen, how some of these things are being done. So I think it will enhance our understanding better. So it's just a suggestion if it can happen. I think for some of us who are ready to learn, we can sacrifice our time and attend the training. It's just in my own opinion. Thank you very much.
All right, thank you, Yusuf, for that. Okay, we'll be having a training, a paid training, but it will be announced to you, or you'll be, and also the WhatsApp platform on when and where the training will take place. So this, I know that this is a lot for you to consume for just an hour and 30 minutes. So I know that you want to really engage. So it will be communicated to you via email and also the platform. So do we have any other question? You can drop your question on the chat box. And also, don't forget to send in your name, the way you want your name to be, the certificate I want it to be. I want you to write it out for me, so that at the end of the training, you will have a certificate for participating in this training. Okay. Mr. Daniel, can you go on?
All right. Good afternoon, everyone.
All right.
Thank,
Afternoon.
thank you, thank you so much for the uh, wonderful and perfect, beautiful presentation, Mr. Ojo. Right? Okay. Like he rightly said, Mr. Yusuf, Mr. Ojo have said, but that is going to send down the lecture notes, and there, from there we'll have another session for training aspect. All right, mine is that I would like to know, after all this, would there be any space or chance for partnership? Maybe after I am an accountant, but I have a little idea in wiring electrical aspects, so I'm in love with this. So would there be any partnership for maybe when we want to go deeper into real life investment into this, maybe where we can get materials, and then maybe installation payments and all of that. So I would like to know if this opportunity will be given, so that we can also stock our business, because as Nigeria is now, it's not easy for someone to just bring millions into a business that is just starting. So I don't know if such opportunity will be given. Thank you.
Thank you, Mr. Daniel, for that question. On this call, we have our MD in person of Dr. Fakunle Aremu. I think that question is directed to you. Dr. Fakunle.
Okay. Yes. Thank you, Mr. Daniel. Thank you, Mr. Ujo, for the training, and everybody for your participation. Yes, for further training, in regards to the first question, for further training, we'll communicate it to you via email and the WhatsApp group. We have training for those that does not have any prior knowledge, understanding of the solar energy, which is the package 1. We have package 2, which is for those that are technicians already, but they want to go further and become engineer. We also have the package as well. And the training is in such a way that we will build you from the scratch to the level that you can write, you can be current certified, NEMSA certified, because we are also working in partnership with other regulatory bodies in the renewable energy sector. In terms of partnership, yes, Cedro has the clean energy aspect of our activity is in 4 areas, and this is just one of it, which is training. Not only solar energy training, we train in other aspects of the renewable energy. And when she was doing the introduction, we serve as a local trainer service provider for some international organization and training institutions across the world. So we provide that, and this is one of it. We also have the package for sales and distributions of clean energy equipment and materials, which is outside this training. So we have opportunity for partnership, depends on what a particular group or institutions or clients or individual want to do. So I will stop from here. And now that you are in our pool, in terms of email and WhatsApp group, we'll be communicating with you other aspects of the services and opportunities that we have in store for you. Thank you so much.
Thank you, MD, for that. Do we also have anyone who has any question? Okay, I saw someone raising his hand.
Yes, ma.
Go on.
I have a question, ma.
Yes, you can go on.
Thank you for the training. My name is Babatunde Raji. So my question now is that since we are part of your student now, if you have solar panel, is there any way you can sell for us, maybe as a discount price, or I don't know. That's my question, ma. Though we want to learn more, but while learning, we want to buy. So where is the office, and is there any discount for we your students? Thank you.
Okay, let me answer. Because of the internet sensitivity, I will cover my camera. Yes, we have. When after the training, once we understand what you want, then we will be able to provide you a customized response and service that you want. I mentioned that we also do sales and distribution. We have network of solar uh, industries and companies. We are based in Abuja, and we also have outlets in Kano. We're also currently working in Lagos. So, but when after the training, if you reach out to Jessica, who is the coordinator, then we will be able to analyze and understand your specific need and know how to engage with you. Thank you.
Ekasa.
All right, thank you. So Joe, we have questions in the chat.
Sorry, hello, can you hear me?
Yes, we can hear you.
So mine is not a question, but I'm having network issues, and you earlier mentioned that you sending our mail. I did
The
send my
network is
response.
bad.
So is there an alternative which we can actually send our name, because the chat here is not actually the message is not that.
We didn't hear you.
Okay, can you hear me now?
Yes, I can hear you.
Please, can you
Okay,
type it? Can you type? Jessica, please, can you receive the typed question if possible? The network seems to be bad.
so what I'm saying is, you earlier said we should send in our names, but due to the network glitches, it's not going through. Is there an alternative for we to send in our names aside here?
You can send it on the WhatsApp. On the WhatsApp.
Okay, all right, thank you.
On the WhatsApp group. Thank you. Mr. Ojo, we have questions on the chat.
Question on the
Yes,
WhatsApp.
Yeah, someone is asking about the average lifespan of the solar system, and also why is it that it's lithium battery that is the best? Some installers use car batteries. What is your take on that?
Thank you for the question. Using car battery is completely out of it. The word car battery, both the car battery and both the lithium battery, they uses tetraoxosulfate acid. But if you take a close look at it or study it closely, the car battery just produces a spark. There's no body. The car battery cannot even withstand one glow for like 2 minutes or 3. It produces a spark. And what happens in the car is that when the car is moving, that battery is constantly charging. It's constantly charging. The solar battery is different from the car battery. And that depends on the numbers of cells in the solar battery. Are you hearing me? Is the person hearing? Please signify if you are hearing me. Thank you. Thank you. So the use of car battery as solar battery is completely a bad habit, and to me it is not possible. So talking about the lithium battery being higher than the flooded battery, the lithium battery is designed with a particular DOD. DOD means depth of discharge.
Depth of discharge.
Depth of discharge. The lithium battery has a depth of discharge of about 80 to 90%. That means you can discharge the lithium battery to as low as 80 to 90%. But the flooded battery has a DOD of 50%. And why do we set it that way? Because Lithium battery is made up of 6,000 cells. When you have a full charge and a full discharge, you have complete one cycle and one cell is gone. Are you getting me? That is why it is not advisable that a solar battery is expected to discharge completely to zero. It is wrong for someone to say my light went off and the solar battery discharged to zero. It's killing the lifespan of that battery. Are you getting me? And because a client cannot maintain or control that, you include it in your design. Whenever we go to the design aspect of it, the calculation aspect of it, you will see it. The DOD will be used in the battery sizing. The sizing of a solar energy system is very important. I told you about performance just now, and I mentioned three key things: site assessment, load audit, and system sizing. Those three things are very, very important. When you don't size your system very well, you are ready to face all those things you are mentioning. So the battery of the lithium is of high efficiency. It is designed of high efficiency, and the high level of depth of discharge that it has makes it the highest and of higher quality. Also, checking from the warranty, lithium battery has a warranty period of around 5 to 10 years. Flooded battery has 12 to 14 months. Flooded battery has 12 to 14 months. When they talk about this warranty period, it does not mean after those periods the battery will stop working. But what it means that after those periods, the battery will be discharging faster than it was from the beginning. And some clients kill the battery themselves. They discharge it to 0.0. Secondly, battery need ventilation. When you are installing for a client or you go for your site audit, ask the client, where do you want to keep the battery? It must be close to a place that air can circulate. Because if you keep the battery in a heated region, it reduces the lifespan of the battery. Is your question answered? So all these are factors that place the lithium battery ahead of the flooded battery.
Thank you very much, Mr. Ojo, for that answer. All right. Do we have any other question?
No question again.
All right. On behalf of Cedro Royal Multiventures Limited, thank you all for participating in today's free solar training. Shared today
Thank
has
you, ma'am.
provided insights and inspired you to explore opportunities within the renewable energy sector. We encourage you to stay connected with Cedro Royal for future training, certification, consulting opportunities, and professional development programs. All right. For those that haven't sent in their names, you can send it through the WhatsApp group. I hope every one of us on this call is in the WhatsApp group. And if you are not, you can drop.
I'm not. I'm not.
Okay, you are not on the WhatsApp group.
Yeah, they just sent me the link, so I joined.
Okay, all right. You can send in your name on the WhatsApp group, and then
Okay.
you communicate more on the WhatsApp group platform. Okay, before I
Okay.
forget, I have the Cedro Royal team on this call. I have the person of Mrs. Feishayo Aremu. I also have Feishara on this call. I have the MD in person of Dr. Fakule Aremu. So thank you all for joining in. And I wish you continue to succeed in all your endeavors. So do have a wonderful day.
Thank you, ma'am.
You are welcome. Thank you, everyone.
for joining in. Okay, there's a question here. I didn't see it. Please, I want to ask questions if we can invite more members, I mean, graduates in particular, willing to learn about solar system. For your office in Kano, can you have internship for graduates that can come and be learn? Mhm. I don't see that question. Okay, there's a question here.
Um, Thank you, everyone. And before we sign out, please, uh, Miss Jessica.
Yes, I can hear you. There is
Okay, please
question.
mute your. Let me give the final word or something before I sign out. Welcome, everybody, and I thank you for your time out. For further training, mind you, this is not all that solar energy entails. Like you all said, your inquiry or your quest for further training is our concern. And just as the coordinator said, you have the platform already to air your view, your point, and so on. And a lot of information will be passed across to you as well. Now, to become a full-time student of this training, the organization Cedro Royal Multiventure will make a provisions for all of that. So please keep your head up and wait for the next informations. We have a whole lot to learn. These are preliminaries. It's an introduction that touches all aspects. There is a detailed lecture with pictures, with practical involvement, and so on, even videos that will present. But Rome is not built in a day, as we all know. So all your questions are taken, all your input and contributions are taken, and will be given due consideration as we go on. Thank you very much for your participation once more, and I appreciate all your, as in all your involvement. Thank you, and may God bless you all.
All
Thank you,
right,
sir.
thank you, Mr. Ojo. MD, do we have any other contribution?
Thank you, everyone. Have a nice day. We have come to the end of the training. Bye.
Hi, sir. Thank you, sir.
Thank you very much.